Good morning, everybody. We are week 14, day 1. Do now please make sure you take out proportional relationships number 4 and check with the answer key. You can also find the answer key on the spreadsheet. For today's objectives, we're going to be doing some algebra, some lightweight algebra. I can solve proportions. Our major unit this first semester is proportional relationships. For next semester, it will be algebra. Language objective is I can set up proportions with units. And social objective is I can count it with my teammates. For the agenda, we'll be doing homework review, followed by notes, then the worksheet, exit ticket, and planner. So you'll need your math notebook, so we can take notes in your math notebook. And I'll open the Jamboard link. Please copy everything you see on the Jamboard. So we're doing some algebra, and in algebra, you'll see these letters called variables, and I want to define what variables are. So a variable, just right in the upper left-hand corner, is an unknown number, something we're trying to figure out. A variable is an unknown number. And it can have any letter. It can be X, it can be Y, it can be Z, it can be J, etc. Okay. So a variable is an unknown number. We're trying to solve for it. Please go ahead and write that down. So when we're solving proportions, we're trying to find an unknown quantity. And you can see number 1 says 12 over 40 equals to 36 over X. We're trying to figure out what X equals. Number 2 says 16 over 75 equals to Y over 15. We're trying to figure out what Y equals. And number 3 says 6 over Z equals 15 over 20. We're trying to figure out what Z equals. These are all proportional. We're just trying to solve the proportions. There are many ways to solve proportions, but usually we want to follow this process to help you solve in the most efficient manner. So strategy number 1, find the scale factor if possible. So 1, find the scale factor if possible. If you cannot find the scale factor, then we want to clear fractions. By multiplying the denominators. So if we cannot find the scale factor, then we want to clear the fractions by multiplying the denominators. We'll do this quite a bit in the first unit in this TANS class for IM1. And then lastly, number 3. Once you clear the fractions, you want to solve for X, solve for the variable by dividing. So first off, find the scale factor if possible. If not, clear the fraction by multiplying the denominators. And lastly, solve for the variable by dividing. Okay, so now that we have written down the general strategies, we're going to go through each one of them, each of these steps one by one to each of the problems. So I'm going to write mine on the right-hand side. You can write underneath, but I'm going to rewrite the problem again, just so that I can see the original problem, what it looks like, and the work we do to it. So step 1, find the scale factor if possible. Can we get from 12 to 36? Yeah. What do we do? 3? No. Add, subtract, multiply. Okay. Whenever we're finding scale factor, we're always multiplying or dividing. So we can multiply by 3. And whatever we do to one side, we do to the other side. Okay. So in this case, 12 times 3 is 36, and 40 times 3 equals x. Class, what's x? 120. Yeah. So we just solve for x. 120. So whenever you have proportions, try to find the scale factor first. It will save you a lot of time. Okay, if you can find the scale factor, you can solve the problem quickly. Okay, for a second problem, I'm going to rewrite the problem again. 60 over 75 equals to y over 15. Can we get from 75 to 15? How? Dividing by 5. Yeah, you divide by 5. Okay. Remember, when you're scaling, you're always multiplying or dividing. So we can, whoa, we'll fix that. Divide by 5 in the denominator, and whatever we do to the denominator, we do to the numerator as well. And what's 60 divided by 5 plus? 12. Yeah. So the second problem, x equals to 12. So 60 over 75 is the same thing as 12 over 15. They're proportional. You're just multiplying it, you're scaling it by 5. And for the first problem, 12 over 40 is equivalent to 36 over 120. We're just scaling it by 3. The equivalent proportions. Okay, so for the last one, I'm running out of space. So I'm going to write in the upper right-hand corner, but you can continue writing it in your notebook in the same location. So find the scale factor if possible. Can we go from 6 to 15? No, not a whole number, right? So this becomes a little trickier. So if we can't find the scale factor, then we need to clear the fraction by multiplying the denominators. So I'll show what that means. I'm going to write the problem in the corner first. So we have 6 over z equals to 15 over 20. So we couldn't find the scale factor. Now we need to clear the fractions by multiplying the denominators. What are our two denominators, class? 20 is one of them. What's the other denominator? Z. So we need to multiply both sides by 20 and z. So on the fraction on the right, I'm going to multiply by 20 and also multiply by z. And then on the fraction on the left, I'm going to multiply by 20 and also multiply by z. And when you clear fractions, it makes your life a lot easier in terms of solving the problem because you don't have to deal with some nasty fractions. So now when we multiply 20 and z both sides, you'll notice that something simplified. The multiply by z and divide by z, they cancel each other out. And then on the right-hand side, the multiply by 20 and the divide by 20 cancels each other out. So class, what are we left with on the left-hand side of the problem? 20 times 6. So on the left-hand side, we're left with 20 times, let me rewrite that, 20 times 6. And what are we left on the right-hand side? 15 times z. Okay? 20 times 6 equals to 15 times z. So we tried step 1, find the scale factor if possible. It was not possible. So we tried step 2, which is clear fractions by multiplying the denominators. So we multiply 20 and z on both sides of the equation. Now we're going to solve for the variable by dividing. Okay? Z is not alone. What's in the way of the z? 15. So we need to solve for the variable by dividing by 15 on both sides. So we'll write divide 15 on the right and divide 15 on the left. And now our new problem is going to be 20, the 15 divided by 15, they cancel out. So 20 times 6 divided by 15 equals to z. 20 times 6 is going to equal to 120. And 120 divided by 15, I think it's going to equal to 8. 120 divided by 15, 8 times 15 is 120, yeah. So z is equal to 8 is our answer. Okay. If you looked at this original proportion, you couldn't tell that the answer was 8. But if you start following all the strategies, you'll figure out that it's proportional with each other. So z is equal to 8. And I can check to see if this is right by simplifying the fractions. If I simplify 6 over 8, that's 3/4. If I simplify 15 over 20, I also get 3/4. So they're proportional. And that applies to all the other fractions above. You can simplify each one of them. 12 over 40 simplifies to 3 over 10. And 36 over 120 simplifies to also 3 over 10. 12 over 15 simplifies to 4/5. And 60 over 75 also simplifies to 4/5. So they should be proportional on both sides. There's a problem number 4, so you can write number 4 after number 3. Okay, so I think I mentioned to you all in the past that the United States is one of the few nations in the world that doesn't use the metric system as its primary form of measurements. We use the imperial system, and only 3 nations in the world use the imperial system. The US is one of the few nations that uses pounds instead of kilograms. So if you go anywhere in the world, you say pounds, they'll be like, what is that? You say, what's your weight? Like 40 kilograms. You say, I'm 70 pounds. So like, what does that mean?
Really?
So if 2.2 pounds weighs 1 kilogram, how much would a 2,500 kilogram pickup truck weigh in pounds? So to solve this problem, we want to convert things by writing proportions. So you can see that it says 2.2 pounds. So I'm going to write that down. 2.2 pounds weighs 1 kilogram. So we're at 1 kilogram underneath. Okay, so 2.2 pounds is 1 kilogram. 99% else of the world uses kilograms as their weight.
Well, who are the 3 nations?
US, somewhere in Africa, and I think somewhere else, like, it doesn't matter. It's where, like, no one uses it. 2,500 is the kilograms. So that would that go in the denominator or numerator? Numerator, denominator. 2,500 kilograms. We want to match up our units. Denominator, yeah. You see 1 kilogram in the denominator, we need 2,500 kilograms in the denominator as well. And then up here, we're going to write X pounds, because we're trying to figure out how much it weighs in pounds, right? We don't know the pounds. So a pickup truck is 2,500 kilograms. Okay, what does that mean? It doesn't mean anything to us Americans because we don't know what kilograms are. So we're going to transition that to pounds. How do I get from 1 kilogram to 2,500 kilograms? Multiply by 2,500. Whatever we do to the denominator, we do to the numerator as well. So 2,500 times 2.2. 2 times 2,500 is going to give us 5,000. We put a placeholder, and the other 2 times 2,500 will be another 5,000. And then we place one decimal place value. So our answer is, I'll write it somewhere at the top, the pickup truck will weigh 5,500 pounds.
Put the 500.
Okay, that is the average weight of a pickup truck. I literally Googled it. So that is very heavy if a pickup truck is on it. Okay, now you'll be working on your worksheet, proportional relationships number 5, with your pair or as a group. Raise your hand when both you and your partner complete problems 1 and 2. That'll be the first checkpoint. Problem 3 will be the second checkpoint, and problems 4 and 5 will be the last checkpoint. An adult signature demonstrates mastery. After you're done with the worksheet, you can do your exit ticket. And then for your homework, it's proportional relationships number 5 and the exit ticket. For IXL, pick between 7J11, which is solving proportions, and 7J12, which is solving proportions of word problems. Each at least a score of 90, and submit your screenshot on Google Classroom. Take care and have a nice day.